right, our next topic is when statements are logically equivalent. And this is actually going to lead us to what is called De Morgan's Law. So that's what we're going to use this as a basis for. So first thing, for if things are logically equivalent, it means they have the same truth values. And the symbol is sort of like an equal sign, but there's three lines there. Okay, so how do you decide if something is logically equivalent? Well, the first thing is you determine the truth value for each of the two statements. Okay, so I'm going to look first at this statement right here, the negation of if P then Q. So what we would need to do first is evaluate the truth of if P then Q. So again, the only time that's false is if we have if P is true and Q is false. All the rest of these will be true. And then I need to negate that. And so that is switching all of the truth values from my previous column. Okay. The next thing I'm going to do is look at this second statement, the P and not Q. So I'm going to do the not Q first. Again, switching the truth values. And then I want to evaluate P and not Q. So I'm looking at the very first column with the P in it and then my not Q column. And for an and to be true, again, both the P and the not Q column have to show trues. And so I've got false, true, false, false. Okay. Now, when you look at the two final statements that we were supposed to evaluate, so there's one and here's the other, you will notice that their truth values are indeed the same. Okay, that means that these statements are equivalent. And so, oops, sorry. Here's my pen. So that would mean that the negation of if P then Q is logically equivalent to P and not Q. Okay, in other words, those are the same thing. So it's just like with an equal sign, you could replace like one phrase with the other if there was a reason that you wanted to look at one in one form versus the other form. Okay, so let's look at this next one here. So the negation of P and Q. So first we'll look at P and Q. Again, for an and to be true, both statements have to be true. And then we want to do the negation of P and Q, and so that will switch all of our previous truth statements. Okay, so this is one of the things we're going to be evaluating when we get to the end. Now I'm going to go ahead and switch to the not P or not Q. So not P would be false, false, true, true. Not Q, false, true, false, true. And then we want not P or not Q. And again, I just need one or the other of my not P and not Q columns to be true in order for the or to be true. So we've got false, true, true, true. And again, comparing the two final truth statements together, you can again see that they line up, false, true, true, true. And so these statements as well, the negation of P and Q is equivalent or is the same thing as not P or not Q. Okay. All right, and then last but not least, let's evaluate these two statements as to whether or not they are logically equivalent. So let's start with the negation of P or Q. So starting with the parentheses, P or Q, again, we need one or the other of P and Q to be true for the statement to be true. So we've got a true, 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 false. And then we will negate that column. So false, 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 true. And just as a reminder, that's one of the columns we want to keep track of when we're looking for our logically equivalent statements. So then next we're going to look at not P and not Q. So not P would be false, false, true, true. not Q would be false, true, false, true. And then not P and not Q is again going to look at those two columns, the last two columns that I just wrote, the ones in green. And for an and to be true, we need both not P and not Q to be true. So we've got false, 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 true. And once again, you can see that our truth values do indeed match up. And so what we've determined in this case is that the negation of P or Q is also logically equivalent to not P and not Q. Okay, these last two, B and C, these are what are known as De Morgan's law. Okay, De Morgan's law. Actually laws because they go together. And really what it does is it tells you how to negate an and or an or statement. So notice what happens. And I like to think of this is not proper mathematics. I'm sure somebody would probably De Morgan turning in his grave. But I kind of think of this De Morgan's law, I sort of think of distributing that little negative, that little negation sign. Notice what happens is it turns the P into a not P. Notice it reverses the and to an or. And then it changes the Q into a not Q. All right, that's how I remember it. Kind of like distributing a negation. Again, somebody's turning in their grave, a mathematician somewhere. But the same thing happens with part C here. So again, if you kind of think of distributing that negation, you'd get a not P. The or changes to an and then you distribute the negation to the Q and you get a not Q. All right, and that will be summarized along with part A, which is how you negate an if-then statement. It doesn't have a special name, but those things are found at the top of the next page. In the next video, what we're going to do is then use those things to then talk about how we negate things in terms of words and or symbols.